Finally done. Got the block ready to go. Got her honed out. You can see the final measurements I'll put up here in a second. Couple vertical lines. Wanted to stay a little bit deeper scratches. Not the end of the world. Didn't really want to keep going. I said this thing had no oil consumption or blow by or any performance issues. Other than that, I do have the block pretty well cleaned up. Got the whole thing coated in WD-40, so got a lot of parts coming. A lot of little stopping points where, oh, well, I need this. Now I need this crush washer. Now I need this O-ring. Now I need this gasket. It's going to be a lot of that going back together with this thing. But that's the business. So I've got these back together, no particular reason. We are not going to reuse any of this. It's too much trouble and too much of a gamble to find a used connecting rod that's going to be the right series. And that's really because of the weight. I kept almost buying one, but not knowing for sure if it had the right size wrist pin, because in 2011, 2012, they went from a 21 mil to a 23 mil. It's a rabbit hole trying to track the TFSI 2-liter motor and what application had what exact parts. Somebody out there knows somebody, but it's so hard to try to get a used one and know for sure it's the right one. So we're getting all new connecting rods and pistons. Not spending that much more money because a good set of Hastings rings, about $100. I was going to get new conrod bolts. I think they're like 12, 20 bucks. And then the price of a used connecting rod was, from what I was seeing, anywhere from $80 to $110, depending on where this thing was. There was one out of like Hungary. I thought that might work, but again, it was a gamble. So we're not spending that much more in getting all new conrods, pistons, rings, wrist pins, hardware, brand new OEM supplier stuff. Not so much aftermarket, but it's a OE supplied OEM. Pretty much what Audi would be putting in your motor if they were rebuilding it. All right, guys, real quick. Got the old bolts in on the number 5 main, new set of bearings. I've got this digital internal diameter micrometer. It's too hard for me to show you. with the angle and everything, but it's 2.29 ballpark. So what we're doing is we're going to take that 2.29. I've set the dial caliper over here to 2.29 just to compare, just to confirm it's correct. We're at 2.29 on the dial caliper. So now I'm going to set up the bore gauge to do the same thing like we did on those cylinders. So what we're going to do is we're going to take the inside diameter of that bore and measure against the outside. Actually, this would be number 5, the number 5 pin on the crank, and you just subtract those two numbers and you get your bearing clearance. Okay, so for the sake of my dignity, we're actually re-recording this. You have no idea what I'm talking about. Well, last night I was in here turning and burning away on this motor, having all this great video and showing you how to mic out your mains and moving mains around to match the crank pin for the tightest oil tolerance. And then I realized something as I was editing the video. I was not reading my own instrument correctly. Basically, as you just saw, we have this set to what we had mic'd originally with the inside diameter bore gauge, 2.29. That only reads to the hundredths. So we set this bore gauge to where 0. So again, I'm pressing in. So I'm closing this inside diameter is getting tighter. So as I push this in, as you saw in the video prior to this, when this needle hits 0, we're at 2.29. Now, if I keep pressing a little farther to the 5, that does not mean we're at 2.295. That means we're actually at 2.285. So I made this entire video last night based off of those measurements, and I didn't catch it. So here I am, Thanksgiving Day. I haven't even started cooking yet. And for the sake of, like I said, my dignity and the internet, I'm not going to bother putting up the old footage and editing everything with, screenshots and stuff. I'm just going to do a quick recap of what we did. But kind of a foolish thing I did, but these things do happen. All right, so now we're at number 5. And there is a familiar mark. Oops. Yep, the dwell of the needle just is on the 5. So the number 5 main is 2.285 inches. So let's move on to number 4. And guys, I had moved these bearings to different positions like 3 different times to get a good consistency to match the pins. And now I fear I might have done that backwards. But honestly, this motor is so much tighter now. I'm not really worried about it. So now we are at number 4. The dwell of the needle puts us at number 6. Just at 6 past 0, let's just call it. So well, that puts us at 8.84. So 2.284. All right, we're going to number 3 now. And number 3 was our problem child from last night. And that's almost exactly the same measurement. Needle peaks right at the 6. So again, we're going to call that 2.2840. So let's go ahead and look at number 2. Well, I said I'll put number 5 back on here in a second. Or number 1 rather. You can just see the needle off screen. Again, it's at the 6th past 0. So 6 thousandths. Again, puts this, so 2.290 minus 6 thousandths. Put us at 2.2840. Go ahead and throw number 1 back on. These are the old bolts. Basically, we've just got a cleaned up block, the original mains, used bolts. I have new bolts because these are not, these are stretch. I don't want to say torque to yield. I think that's the right term, torque to yield. They're one-time use bolts only. The book usually tells you, any engine, any builder's guy is going to tell you to torque these to about 50 foot-pounds. These do have cross bolts. We're not worried about that right now. We're just getting the preload so we can mic these out. So again, 50 foot-pounds. I did oil the threads. Like I said, when we get to putting the crank in, you'll see exactly the right torque sequence. I'll bring up the book. I'll have the page up on the screen. We'll be doing this together. So let's go ahead and mic this one out. Sure, it's a good thing I wasted all that time last night. I'm not going to bother moving this stuff again. Alright, so number 1, the needle is dwelling, it's between the 5 and the hat and the 5.5, not exactly 6. We'll call it right in the middle. So that's going to be 2.2845. So that's as far as we need to go. I'm not going to mess with matching these up because, let me explain. Okay, so we have number 1, 2, 3, 4, 5, etc., etc. These are what they measured out to. I took these about 3 different times with a mechanical dial caliper, 2 different digital ones, and these are the numbers I'm most comfortable with. These are what they all average out to be within a couple thousandths or a couple 10,000ths of each other. So I went with the most consistent measurements. This is a used crank. I believe came out of it was an A4. We have a low mileage oil pump. We got out of an A5, had about 50,000 miles on it. And I think this actually came out of another TT. I think this came out of a Cabriolet, or the Roadster, the convertible TT. I don't remember the mileage on this crank. I know the oil pump's about 50,000 miles. This came out of an A5, I believe. So I'll have to change the sump out, which is fine. I cleaned the old sump up, or the pickup tube rather, not the sump, and I got new O-rings and all that fun stuff. Anyway, but here we go. So basically what you're going to do, you're going to take your outside diameter, your inside diameter of the bearing. Let's say we're number 1. So it's 2845 minus the outside of the crank pin on number 1. So 2830. So that gives you 1 in 5/10,000ths clearance, which I'll pull up the manual here in a minute. In fact, that's measuring our clearance, which is fine. But what I did last night, and this is kind of an old school trick, aside from running thicker oil, you want to mix and match your bearings. You want to put smaller with smaller. So for instance, our outside on number 1 is 2830, but the inside on number 2 and 3 is 2815, which is a little more down. The centers are wearing down a little farther than the outsides, as you can see, because 2, 3, and 4, you know, 15, 15, and 20. And the outside, you have 30 and then 25. obviously all your majority of your force is getting transferred to the center of the crank. Again, number 3, where your thrust bearing rides. So I'm kind of going all over the place here, but like I said, the point is you would want to match in an ideal environment. You know, you have 840, 840, 840. That's a tighter. It's a little bit tighter of a circle, correct? So you would want to put those in the positions where they're where the pin is wore down a little bit more, so it matches better. And coincidentally, it's already pretty much set up that way. I mean, it's almost on the money. Well, again, this is backwards. You have to imagine it's, but more or less, it's about right on the money. So there's no point in moving this stuff around when you're talking 10,000s, because a lot of times, as for instance last night, I had moved these around to better match the coordinating pin, and that may be why our measurements are what they are. These two didn't really move. These 3 did slightly, but number 3 was a problem child. Number 3 measured incorrectly the first time somehow. But again, I'm kind of going off on a tangent here. Point is, like I said, here in the video, we're gonna go over the numbers, and we'll give you the exact clearance and what the book says is good. All right, guys, what we have here is a chart I made to help show you what's going on. Obviously, we're measuring the crankshaft. We're measuring the outside diameter of the pins on the main journals 1 through 5. Keep in mind this is a used crankshaft. It is wore down slightly. It's not excessive. It is still within spec. It's getting close though. It's kind of a gamble. But because of this, we are going to run a thicker oil. We'll be running a 540, which is also a recommended oil from Volkswagen Audi Group. They call for 040 when it's new. It's kind of an old school trick. It's certainly not going to hurt to run a thicker oil. This is what we're measuring from. This is ideal. This is what a new pin diameter is, and this is what we measured. Obviously, you can see the difference here. Moving down here, now we do need to use these numbers in this formula. Down here on the main bearing clearance, this is rule of thumb for engine building. It's 1,000 clearance per 1 inch of pin material. So, for instance, on a brand new pin, a brand new crankshaft, brand new motor, plus or minus 5,000. This is ideal. This is the ideal number you'd be looking for. This 7 would be a 2, would be 0.022.834, but you are allowed up to 5 10,000ths additional plus or minus to run a little looser or a little tighter. You know, that works in our favor here because our bearing clearance is on the looser end. That's why I have these max numbers here. It's not loose, but it's between ideal and loose. So, like I said, it was why we're going to be running a slightly thicker oil. You can pause the video and kind of study up on this. Basically, you're going to be subtracting your inside diameter from your outside diameter, and that's going to get you your clearance. Same thing on number 2, your inside diameter versus your outside diameter, because these main bearings are going to encapsulate the crankshaft. So, that looks a tad excessive. We're at 25 10,000ths. But like I said, that's where we're just running it a little bit looser. Pretty much that's it. Other than, keep in mind these are not exactly as accurate as they could be, but they're within a few 10,000ths. I will say that. I mean, like I said, I've measured these enough times with 3 or 4 different materials or different instruments. Other than that, thanks for watching. It's been a lot of fun so far. It's taken a little longer than I'd like, but that's just kind of how it is.